Next, let's do homework on page 897. I have found besides the examples in the book, and please do all the examples in the book carefully. Okay, that should enable you to do most, if not all, the homework. And the homework I assigned on this page is problem 13, 17, 23, 25, 29, 33, 35, 39, 41, 40. Can't see it. 42. What? Oh, never mind. 42, and then 45, 51, 53, 67, and 69. And most of them should be very short. Okay. Yeah. Maybe all of them, I don't know. So, and it's nothing like the systems of equations or the matrices. Those were the tough days, but now we are in for a easy sail. Okay, so please do your homework, and when you're done, I want to talk about some of them. Okay, now that you're done with homework, I want to talk about problem 23. Now, at first sight, problem 23 doesn't look like it has much of a rhyme or reason. But if you look at it more closely, you can see the pattern like this, okay? The first one is just 1, which we'll call it 1 over 1. Let's see, 1 over 1, okay? The second one, we'll call it 2 over 2, I guess. And then let's see, the third one is 4, okay, over 3. And then the fourth one will be, what? Okay, then 4 over 8, okay, and which is 2, and then 5 over 16. So now you can see a better pattern if it's written like this. That is, the bottom goes 1, 2, 3, 4, 5, okay, and the top is 1, 2, 4, 8, 16. Which means that the bottom goes as just n. That is, an equals to a fraction, okay? And where the bottom is just n, see, n equals 1, 2, 3, 4, 5. But the top is equal to 2 to the power n, n minus 1. It is missing 1 because when n is 1, it equals to just 1, and the only way that's going to happen is if it's 2 to the power 0. So it's moved back by 1 that way. As a result, we just call it n minus 1. So to the second term, when n equals to 2, then 2 minus 1 is 1, so we get this one, and so on. As you can see, that's how we come up with the answer of problem 23. So problem 23, the answer is correct. I checked. So let's now move on to problem 35. Now problem 35, we have to write a recursive formula for this thing. All right. So let's look at this thing. And you notice that there's a difference. The difference here is that's minus 8 if we have plus 2. Okay? That becomes minus 6. And minus 6 plus 3 will be minus 3. And minus 3 then plus 4, it will be equal to 1. And 1 plus 5 will be equal to 6. So you notice that the addition amount is increasing one at a time in a steady way. So then, but this is not a linear relationship because the difference is increasing. Okay, and it's increasing by 1 at a time. So we are supposed to write a recursive formula. That means we start with the first one and then define this following one by the guy previous. So first, to do recursive, first we say a1 equals to 1. A1 equals to 8. That's the first one. So far, so let's write down a1 equals to minus 8. So far, so good. Okay, and then what? And then we write down, so then an. So an is equal to an minus 1 plus a certain number. Plus what? Plus this is the previous number that is n plus 1. Okay, that is for example, if n equals to 1, then if start at n equals to 2, a2 will be equal to a1. That's n minus 1, okay? a2, which is minus 6, will be equal to a1, the one before, minus 8, plus, this is for n equal to 2, okay? For n equal to 2, a2 is equal to minus 6, which is a1 plus n equal to 2. Let's see. It wouldn't be plus 1. It just n is good enough. Plus 2. Because we are talking about the second one. So I guess I don't need to worry about the plus 1 bit. Okay? We'll just get rid of that. And that an minus 1 plus n should do it. Yeah. And then we can check again. See, when n equals to 3, the third item, then a3 will be equal, a3 is equal to minus 3. And minus 3, that should be equal to a2, a2 plus 3. Okay? And a2 is, and minus 6, which is minus 6 plus 3, is equal to minus 3. See, it does check out. So this formula right here, it should be our answer. Okay, so let me check. That's problem 35. A1 is minus 8. An is an minus 1 plus n. So that you just kind of, well, arrange it a little bit to make it work out. So that's problem 35. So next, let's do, I want to do problem 42, which is a very short one, okay, which is why I want to do it. Now, we have 100 factorial divided by 99 factorial. What is the factorial? Remember, the factorial means the number 100, okay, times the number before it, which is 99, and then times 98, and so on, and go all the way down to times 1. That's the factorial. And so is 99. So when it divides by 99, so 99 is being multiplied by 98, and so on, all the way down to 1. So if you have a fraction like that, then this is just equal to 100, because everything else is got canceled out. See, all the way down to 1. Everything is canceled out, so we just have 100 left. So it's, the factorial is often a very short problem. As long as you remember what it means, that's all that matters. Next, let's look at problem 67. We are given that the sequence an is presented this way. All right. The question is, what about this number? Is this part of the sequence? Well, we can figure that out by setting this number equal to an and see if we can figure something out. Okay, minus 6 minus 8n, and that means 6 minus 421 had better be equal to negative 8n. Okay, or n equals this number divided by 8. Minus 8. Okay, so we'll move. So n equals to, yeah. So let's pull out the calculator and see if that gives us anything that makes any sense. Let's see, where's my calculator? Here it is. All right. So here we are. So let's do the division. Okay, I use parentheses. Okay, because we have a subtraction here. So 6 minus 421 divided by negative 8. Okay, that gives us this. That gives us some kind of a fraction, and the sequence is defined by whole numbers. So that is not an option. The answer then, unless I punched in something wrong, it looks okay. So then the answer is no. That is not part of this cannot be part of the sequence, because it's the sequence is when you plug in n and come up with numbers, right? So n couldn't be a fraction, and that is not how it works. And I checked the answer for problem 67, and I'm right. Okay, the answer is no. This does not belong to the sequence. So let's continue to problem 69, where we have a bunch of weird numbers. Okay, 1, 0, etc. And we're supposed to figure out a recursive formula for this, and the kind of recursive formula that's based on two numbers. Okay, so let's do that. The recursive formula based on two numbers is, let's see, how does this one relate to these two? Well, I have to say that First, if you look at the pattern, not that this doesn't concern us really, but you notice that the pattern is that this is the repeating point. That is, it start here, and it says 0, and then and it goes 0 again. You notice then it repeats everything after 0, okay? Again and again. It's just a repeating thing. I just happen to notice that, not that we care, okay? So, but anyway, the point is, you notice this will be called A1, and this will be called A2. What is the relationship of A3? Well, A3 appears to be A2 minus A1. So A3 equals to A2 minus A1. So is this the pattern? That is A4 equal to A3 minus A2? The answer is yes. Okay, so I'll write that down. A4 equals to A3 minus A2. And then that's 1, 2, 3, 4. And 5 is A5, A4 minus A3. Yes, it is. So we have, that's good enough for me. Okay, let's start working. And so then the general pattern is we have A1 is 1, A2 is 0, and then n is equal to an minus 1 subtracted by an minus 2. That is, it is each number is the number right before it subtracted by the number right before that. And that is the answer. So that should be the end of this section.